So today I'm very thrilled to welcome David Vike to the stage. He will be doing a super demo for you all. Just a few housekeeping notes. If you were not able to get a headset and would still like to listen to the presentation, feel free to come forward. When the presentation is over, we'll just ask that you put your headsets back at the table where you got them before you sign out. Now I will hand it over to David.
Thank you. Hi all, my name is David. I'm part of SAS R&D, and what I'm going to share with you today is going to walk through the whole SAS Viya platform where we make use of LLMs, and our kind of task here is to put an actual use case into production. And where this always starts off with is, as an organization, I first have to decide which LLMs are actually okay for me to be using in my company. And for this, we have what we call the LLM model project inside of SAS Model Manager. Now, what this allows me to do as an organization is register all the LLMs. Doesn't matter if it's a proprietary model like from Anthropic or from OpenAI, or also open source model like the Llama family from Meta, or even models like DeepSeek that come out of China, or the Qwen model. So it's kind of completely agnostic, and I can now manage who has access to them using the SAS Viya authorization system. So maybe different departments within my company have access to different LLMs, right? For the HR department, when they want to build with LLMs, they can only use on-prem models. They are not allowed to send that data out of our company. Whereas marketing, if they want to play around and do stuff, we don't care, right? Just do whatever you want. And with these different LLMs, there isn't the best LLM out there. There is not one LLM that stands above the rest. And you might have seen a lot of benchmarks online, but when you work with them in reality, it really comes down to your use case. And I always like to talk about 3 metrics when you are working with LLMs. One is cost, right? What does each request cost me? Then is how quickly do I get a response back? And then finally is, of course, the quality of the answer. And as with any piece of technology, this is a balancing equation, right? I can always use the most expensive model, but that might be slow to answer, but has the best quality, but is super expensive. Does the business case support that? So what we can do in here is go actually into this prompt engineering interface, and we are going to set up a new project. Now, a project is a container for all of our prompts that we are going to build for one use case. So as a project name, we are just going to do super demo here. And we create that project in the background for us. And now we're going to create a new prompt. And our new prompt will be recommend write, where we want to build an agent that can recommend a Universal Studio Ride for us, right? We're all going there on Thursday, but we don't know what to write. Well, we'll probably write all of them, but let's see. And then I can select from the models that I'm allowed to use where I want to prompt against. So let's do a fun mix for picking something very common like GPT-4 Mini. And then with these models, you might hear things like temperature, top P, top K, all these different things. You might not know what that is. So we built in a little hover where you can then read up what these parameters actually do and mean, so you can adjust them to your liking. Let's also pick like a very, very small language model. This only has 360 million parameters, so don't expect anything great from it, but it's essentially free to run. And then we are also gonna be picking a big open source model from Meta, which is really big, 405 billion parameters that we can make use of here. And now we can start writing our prompts. And usually what you do is you split them into how the LLM should behave, and then you give it the piece it should behave on top of, usually called a system prompt. Essentially, that's what my manager tells me to do, right? And then the user prompt is what I make of it and my specific input. So here we're just going to put something like, you are an expert for Universal Studio Florida, and based on the user's thrill factor, you are going to recommend a ride. And then on the right-hand side, I have two options what I can do here. One is free-form text, like you would maybe be using a chatbot, or you can also do a structured input. So in my case, I'm gonna use this. I'm gonna say thrill factor. I'm gonna put 10. We wanna go all out here. And let's run our experiment. Now what happens in the background is this prompt that we have is sent against 3 different language models, right? So from GPT, from OpenAI, which is running on Azure in this case, small LLM, which is running on a CPU in my local instance, and then this big Llama model is actually running on Intel hardware. If you're interested in that, I have a spotlight session on Thursday afternoon. So that's a really cool one where we dive deeper into the hardware required for this stuff. And then we get back our prompting results. So we can take a look at what all the different models responded to. We get a reminder of what options we sent along with it. And really critical from an organizational standpoint, what you can see here as well is the amount of output tokens. That's what's usually very expensive, and the amount of input tokens we sent to the request. And then also how long it took to respond to our question that we sent to it, right? So depending on your use case, if you would have 10,000 users running against this, you might need to scale up or down resources for this. And also depending on the business value, is this something you can work with as a business? And here we see a difference, especially in the runtime that these models, maybe even in the quality of the answer, but this took way longer to respond, right? OpenAI took 2.6 seconds to respond. This here took around 6 seconds. But this request is free. This is running on a CPU that I've just lying around, right? We all have spare capacity on CPUs lying around. So that's kind of slow to respond. And then we also have this giant model that is kind of slower to respond, but compared to the sizing difference, it's still very fast to respond. And I actually think from just what I look in here, the Hollywood Rip and Rock ride is one of the favorites, I think, on the Universal lot. And that's actually really powerful roller coaster. So I'm just going to accept this as the best model respond. Now, the prompt engineering, that's something that regulation is coming up with, is now saying you need to version these prompts, you need to save them, you need to treat them as any other modeling asset in your company. So what we can do here is save or even manifest the prompt, which will make it available for us to reuse within SaaSVIA all over the place. And that's showcased here through a link back into SaaS Model Manager. So in SaaS Model Manager, we looked initially where we had all the different models in there that we deployed and made available. Now we're taking a look at the prompt. And what happens here is that SaaS generates 2 assets for me. One is the actual scoring function that contains the selected model. It has all the wrapping, so it's easily deployable as a unit from a kind of regulatory perspective. And we also get all the experiments that we ran in here so we can work with them again next week, show them to the regulator how we iterated through everything. So everything is saved. And if we were to iterate on this, this would also generate new major and minor versions of the model. So with this piece, we could now move on and build on top of it. Now you can, in SaaS, you always have an insane amount of flexibility on how you interact with the SaaS system. So I could go code with this in Python, I could code in this through REST APIs, I could go into SaaS Studio and work with it through something like Proc HTTP. What I'm going to be doing, because I think it's the most visual, and we'll be also deep diving this tomorrow in the main session, so you're getting kind of a sneak peek, is we are going into SaaS intelligent decisioning, which allows us to combine models with business rules and data queries to build up contained workflows that can actually drive changes within your organization. What we're doing here is we're just going to click New Decision, right? Give us an empty shell that we can work with. We have to give it a name. We can also specify where we want to save it, and we can even attach a workflow to ensure things like 4i principle and enhanced documentation. We are skipping that because we're doing a demo, and in demos, we don't care about that stuff. So we get our decision flow, and a decision always has an entry and an end. And you can kind of think of this as a transactional piece. And in here, we are now going to be making use of that prompt that we just generated, and we're going to send that prompt off to an LLM. For this, I'm just using the context menu. It's giving me a search bar that I can dig into. And remember, we called our prompt up here. We called this recommend ride. So let me just search for recommend. And it will come back. The system is a bit slow because it's in Frankfurt. I'm from Germany, so there's kind of a delay through the VPNs. Everything takes a moment. So now we have added our model, and you can also see I can have that connection back into SAS Model Manager to see what does this thing actually do. And now we want to hand off this prompt to our LLM. For this, again, just the context menu, call LLM. Whoops. Added it the wrong way around. And now I have this pink node, which I can make use of to send the output of my prompt to my actual LLM. So I actually already have done most of the work. The only thing that needs to be adjusting, our strings have a default length. That default length is 100, and we don't want no, we're actually good, I think. We have a small input. So let's go to scoring. Let's say we create a new test. Scenario. Scenarios allow me to generate specific declarations of what I want to have as an input, and can also make use of this to do kind of regional tests where you have outliers, for example. You have all missing values and can kind of see how your decisions behave on this. And for my user prompt, I'm just going to set frill, what do you call factor? And I'm going to put 10 again. And now I can hit save and click run this scenario. And this will then send off my simple prompt against the LLM and return my testing result back to me. And if we click in here, takes a second again, always a bit with the connection. Oh, and we actually got an empty response. Of course, when I demo things go wrong. But usually that's where our LLM response would be sitting in. Let me do the following and grab a pre-recorded video of this, where I can just quickly showcase it. Where is it? There we go. So I'm just quickly jumping into this piece. There we go. Let me go back. Good old demo effect. There we go. So here we asked the LLM to write email drafts for me, and it responds back with email text that I can make use of. So it's the same kind of output structure. But I mean, LLMs sometimes misbehave and return empty results. So that's what we are seeing in this case here. But it's the same variable, so that's where it's coming from. And now, when these things are running in production, as IT, but also as the business unit, I want to kind of monitor what are things actually doing behind the scenes. How is everything working? So all of these LLMs are wrapped in a way that you can have a standardized logging and monitoring on top of it. And of course, there's a SAS dashboard for this. Wait, let me go my favorites, use case, and then decisioning. Where is it? Logging and monitoring, and the baseline. And that's just an example where I ran the same prompt against multiple different LLMs. I think, 18 in total. So the same prompt against all these different LLMs. What I find interesting is how different models respond already. So here you can see the amount of tokens they answered with. And that's a huge variety in response lengths, even though they all had the same input. So if you look here, Claude 1 responded with 311 tokens, while the model with the shortest response only had 150. Right? These are the types of things you need to keep in mind and test and monitor over time as you are using these LLMs in production. We can also take a look at the response times that we have. And what's noticeable here is the models at the top take very, very long. But this was a test running these models on CPU, which again is great for costs and running them on-prem, which makes it possible that you can price them essentially for free. So this was a chart I did for my boss when he asked me, how much money are you wasting with all the testing you are doing here? I said, well, for the proprietary models, here are the specific costs listing for this request, what it costs. And for the ones I'm running on CPU, I'm assuming zero costs because I'm using spare CPUs that are just lying around. And again, here I think it's very interesting that the most expensive model costs 1.4 cents per request, while the cheapest one is such a low fraction that again, if you were to just run this one request, Google would just say, nah, it's free. We don't want to charge you for that. It's too much hassle to charge you. It's on a monthly basis, so one request doesn't really cut it anyways, but there's a huge spread in here. And if we look, if you go back to the tokens and take a look at the kind of response, it's a bit small. Let me see if I can make this a tad bigger here for you. There we go. So we always had that the assistant should summarize the user's input, and then we can see what the user actually gave. So that was consistent over all of them. And then we can see the actual summary that the LLM provided. That might not work because I'm zoomed so much in. Well, let me zoom back out on this. And let me just grab this piece. So here we can actually see that was the summary from all of that input that the user provided. Right? Now we need to, as we monitor these things over time, we can also make use of some of the advanced features in SAS Analytics to, I think this won't work right now because it's too little text. But the idea is that we have text topic modeling right in VA. You can just drag and drop this into your report without doing any analytic stuff. And you can use that to see what are people talking about with my models without having to do the work yourself. And that kind of enables us to do the monitoring and the management of the models, which departments can use which. And then the decision that we built is now not only usable within intelligent decisioning, but if we go back out here, we can go to, validate before you publish. SAS is always very correct in telling me what to do. Well, let's see. Everything finished and was okay. So now I can go ahead and publish. And this now gives me the capability of publishing this very small agent that I built that can recommend writes to me to different container runtimes. Of course, all the cloud providers or on-prem are available, and also capabilities to run this in batch, which would be the CAS engine, or kind of transactional real-time scoring engine that SAS Viya comes with out of the box. Now there's so much more to this where we can deep dive on how you would do this in SAS Studio if you're more of a coder, but this hopefully gives you a great overview of what's possible when you're using SAS Viya to build your own use cases with large language models and make use of them in production. Because now, when my boss asked me, well, did you write any documentation on this? Of course I didn't. but I can just tell SAS to create the documentation for me. So again, if the regulator comes breathing down my neck or internal auditing departments ask me, I can be like, yeah, here you go, here's all the documentation. Of course, I always had that ready to go, right? I don't need to do that stuff on my own, and it's very helpful to have me doing what I like to do and not document things all day long. So I hope you enjoyed this super demo. If you have any questions, I think we have a microphone, so please wait for that to come around. Yeah, thank you. Are we on time? Oh, sorry, I talked too long, but I'll be around, so just catch me there.